Modern means of transportation and communication have been revolutionized. The equipment like computers and robots have also been developed. You can attend the class in this problematic period by means of online class. Everything is made possible by electricity. So our today's topic is electricity. The term electricity is derived from a Greek word, amber, which means electron. A body acquires charges as a result of excess or deficiency of electrons. This type of charge is called static charge. A body gets positively or negatively charged due to the transfer of electrons. Everything is made up with atom. Here, let us consider a helium atom in which true protons, true neutrons, and true electrons are there. This is a nucleus in which there are protons and neutrons. It is revolved around by the electrons in the orbit. The charge of each proton and electron is E. Charge of one proton is plus E. Charge of neutron is minus E, and neutrons are uncharged. They have no charge. Let us calculate the total charge of this atom. Minus E plus E plus E minus E. These two cancels and these two cancels. So the total charge is 0. If we remove one electron from the orbit, what will be the total charge? Minus E plus E and plus E, then we have true positive E minus 1E, we get E, positively charged. If we remove one electron from the atom, it is positively charged. If we give one more electron, let us consider one more electron is added, then what will be the total charge? It will be minus E. The total of this charge will be minus E. It is negatively charged. So we can say that when we remove an electron, it will be positively charged. If we give one more electron, one or more than two electrons, it will be negatively charged. A body is said to have one coulomb of charge if it has an excess or deficit of 6.25 into 10 power 18 electrons. Also, one electron carries 1.6 into 10 power minus 19 coulomb of charge. This is not written in your textbook. You have to write somewhere on your textbook. Now, characteristics of charge. Point number 1. The force of attraction or repulsion exists between two electric charges. Like charge repel and unlike charge attract each other. Point number 2. They obey the principle of conservation of charge. That is, charge can neither be created nor destroyed. They just move from one body to another. An electric field is a region around the charged body within which a unit charge experiences a force of attraction or repulsion. Let us consider a positive point charge plus Q located at this point. If this is the space around which it can experience force, I mean electrostatic force. Within this region, if we put another charge plus Q, this will repel in this direction. And if we put another charge, negative charge minus Q, near it, it will attract in this direction. And again, if we consider another charge outside the electric field, let it be plus Q, this will not experience force on this charge anymore because it is outside the electric field. So we can say that this circle is the electric field. Actually, it will be a sphere. Let us consider a source charge plus Q capital Q located at this point. Suppose this is the electric field of this plus Q. If we want to move another charge inside it, suppose we want to move a charge, another positive charge from this point to this point. Let it be point A. Work has to be done because this will repel in this direction. Work has to be done against this force. Means we have to apply some force, and there will be some displacement. Force into displacement is work done. So the potential at this point A is the work done in moving a charge from infinity to point A. This is considered as infinity because it is outside the electric field. The potential is 0 at infinity. Work done per charge, it is plus Q. So this will be the potential at this point. The work done in moving charge from infinity to this point A against the electrostatic field. So this is called potential at point A, VA. Let us consider 2 points A and B such that A is closer to the point charge Q. It is a source charge. Here, if we want to move a charge plus Q from B to A, we need to do some work. That work will be done against the electrostatic force, the electrostatic repulsion. It will repel. To move this charge from Q to B to A, work has to be done. Then this work done from B to A against the electrostatic field due to the charge is called potential difference between these 2 points. It is VB minus VA minus VB. VA minus VB. Here the potential is more at A as compared to B. The SI unit of electrostatic potential and electrostatic potential difference is volt. It is denoted by capital V. Number 1, potential, 1 volt of potential. 1 volt of potential at a point. Potential at a point. Let potential at a point is 1 volt. What does it mean? By definition, potential at a point is work done per charge. Okay, work done divided by charge. It will be from infinity to point A. Let it be point A. Here, let this point be A, and this is the direction of the electric field. If we want to move a charge, 1 coulomb of charge, 1 coulomb of charge from infinity to this point A against the electrostatic field, we need to do some work. Here, for 1 volt, 1 joule of work is done in moving 1 coulomb of charge from infinity to this point. So we can say that the amount of the potential at this point is 1. Here, work done is 1 joule and the charge is 1 coulomb. Then the potential at this point is 1 volt. Here, this V denotes potential at the point A, and this V denotes volt. The potential at point A is 1 volt. It may also be potential difference. If we want to say 1 volt of potential difference, we have to consider 2 points. by definition, potential difference between 2 points VA minus VB is equal to work done in moving a charge from B to A, work done per charge. Okay. This VA minus VB is also denoted as V. They have the same expression. Let's consider 2 points, point A and B. Here, point A is higher potential, so it will be closer to the charge, the positive charge. If we want to move a charge, one coulomb of charge from B to A, point B to A against the electrostatic field, we need to do some work. If the work done is 1 joule, then we can say that the potential difference between point B and point A and point B is 1 volt. The potential difference is 1 volt here. Okay. Here, work done in moving the charge from B to A is 1 joule, and the amount of charge is 1 coulomb. Again, then we get 1 by 1 is 1. The unit is volt. So we can say that 1 volt. Volt is same as joule per coulomb. The potential difference between 2 points is measured with a device called a voltmeter. It is always connected in parallel to the remaining part of the circuit.